Okay, so this is the first skill of Unit 6, which is all about shapes and particularly about angles. We're going to move on to angles for the remaining skills. There's only 6 skills in this unit. The first skill is about quadrilaterals, and all a quadrilateral means is a 4-sided shape. So let's just note down that this is a 4-sided shape. And there's 6 different standard quadrilaterals that you need to be familiar with, and I've drawn them down here. First one is a square, so you've got 4 sides of equal length, you've got right angles. Here you've got right angles at every corner, but the sides aren't all of equal length, you've got 2 pairs of equal sides, and that is going to be a rectangle. Up here we've got a shape which has got some symmetry, it's got some equal pairs of sides, these 2 are equal, these 2 are equal, and this we call a kite, and it looks exactly like a kite that you would go and fly. Shape over here that's often forgotten is the trapezium. It looks like the roof of a house, and you can see that you've got a pair of parallel sides there, so we'll just make sure we've got that labelled down as a trapezium. Here we've got a square which has been shifted, so we can imagine that if we'd created something like this square, but rather than fix the sides, fix the angles at 90 degrees, we'd put them on hinges and shifted them over, we would end up with this shape. It is called a rhombus. Okay, do not use the word diamond, it's not a diamond. Diamonds don't necessarily have equal sides here. It's a rhombus. All 4 sides are the same length, it's just we don't have a 90-degree angle. And finally, exactly the same thing, so we can imagine a rectangle where we, instead of having 90 degrees, we put them on hinges, shifted it over, and we're left with a parallelogram. So the parallelogram is to the rectangle what the rhombus is to the square. They're both shifted over and on hinges. So I'm going to work through the parallelogram example for us, and then I'm going to let you do the same for the remaining shapes. So we're looking at the parallelogram here, and I'm being asked a number of things. How many lines of symmetry are, what the order of rotational symmetry is, how many pairs of equal sides there are, how many pairs of parallel sides there are, whether or not the diagonals have equal length, and whether or not the diagonals cross at right angles. So we're going to start by looking at the lines of symmetry. Now, what I've done here is I've cut out exactly the same parallelogram as we've got on that shape. So there is my parallelogram. Now, people often think that there might be a line of symmetry which is going down the middle here, halfway along. So let's just try it. If it works, when I fold this parallelogram, we should get the corners matching up. So I'm going to try folding it along that line, and what you should see is that these corners really do not match up at all. There is no line of symmetry there, so that's not a line of symmetry. How about along the diagonal? If I tried folding it across that diagonal, could I get the sides to match up? Well, again, there I folded along the diagonal, and you can see that the sides really don't match up. Let me try along the other diagonal, and again we should be able to see when I try and fold it along the other diagonal that again the sides clearly don't match up. I've got a corner here and I've got a corner sticking out there. There's no way that those sides match up. So a parallelogram has 0 lines of symmetry. So in your table you can just put a 0 in the lines of symmetry there. The second question asks me, what's the order of rotational symmetry? Order of rotational symmetry is how many positions is it identical in a complete turn. So this is my first position here. So every shape has got an order of symmetry of an order of rotational symmetry of at least 1. I'm going to start turning it round. So when I've turned it round through quarter of a turn, it obviously doesn't match up on itself. Here I'm going to have turned it round through half a turn. Notice, when I turn it round through half a turn, it matches up on itself perfectly. So that's the second position in a full turn that it matches up on itself. There's no more positions until I get back, having done the full turn where I started from. So in total, in every 360-degree turn, there's this position or there's this position. There are two possible positions where it matches up on itself. So the order of rotational symmetry there is 2. If you need to cut out any of these shapes to work it out, please do. Then the rest of the questions are somewhat easier. How many pairs of equal sides do I have? Well, this side here with the red tick on it and this side here with the red tick on it are equal lengths. I've got one pair there. The top with the green tick on it and the bottom with the green tick on it are also of equal length. If you need to check, you can do so with a ruler. So I've got 2 pairs of equal sides. How many pairs of parallel sides? Well, again, this red pair, I'm going to put an arrow here, and this side here is parallel. They don't get closer, they don't get further apart, they maintain the same distance apart. So that's one pair. Here I have my second pair. So again, 2 pairs of parallel sides. The next part asks me whether or not I've got diagonals of equal length. So I'm going to draw in now the diagonals. Here, the diagonal goes from corner to corner. So there's my red diagonal, and I'm going to do also a blue diagonal here. Are those lines of equal length? It should be pretty clear to us that the blue line is a lot longer than the red line, so the diagonals are not of equal length. I'm going to put an N there to say no, they're not equal length. Do the diagonals cross at right angles? Does that look like a right angle to us? No, it doesn't. So the diagonals do not cross at right angles. So those are the fundamental properties of a parallelogram. What I'd like you to do, please, for me, is to try and write in for your table the fundamental properties of the other quadrilaterals. Okay, can you just check your table for me? I've drawn on all the shapes the lines of symmetry. Just be really careful with the rectangle. People often think that there's a line of symmetry going along across the diagonal. If you try and fold a piece of paper in half from one diagonal to the other, you will see that that's not right. Here we've got one line of reflective symmetry, here we've got one line of reflective symmetry. The diagonals of equal length should be easy for us to spot when we draw those diagonals in. So I'm just going to show that for the rhombus, what happens when we draw those diagonals in. We should see that there's a short diagonal here that I've just marked in with red, and a long diagonal that I'm going to mark in with blue. So those diagonals clearly aren't of equal length, but they do always meet at right angles. Okay, very well done.